Taproot Assets. It's a Taproot-powered protocol for issuing assets on Bitcoin that can be transferred over the Lightning Network for instant, high-volume, low-fee transactions. Hi, I'm Hannah with Lightning Labs, and this video is an introduction to the Taproot Assets protocol. First, I'll tell you a story about the multi-asset Lightning Network. We can imagine the Lightning Network with lots of nodes connected to each other via channels full of Satoshis. Then let's imagine the edges of the network. We have channels with various assets in them. Assets can be sent from one side of the network through all the Satoshi liquidity in the middle of the network out to another node at the other end of the network. Now let's imagine that we have Alice. She's from the States, and so most of the transactions she makes on a day-to-day basis are denominated in dollars, and so she holds a US dollar stablecoin on the Lightning Network via Taproot Assets. Alice is traveling for a conference and is in Berlin, where she bumps into her dear old friend Roberto from Mexico, who holds a peso-based stablecoin. Alice and Roberto decide to catch up over lunch and head to a nearby restaurant. After lunch, Alice pays the bill, and to do this, she uses her US dollar stablecoin. But the restaurant, being in Berlin, opts to receive her payment in a euro-based stablecoin. Roberto wants to pay Alice back for his half of lunch, and he can do that using the peso stablecoin that he holds, but Alice can opt to receive his payment in Satoshis. All of these transactions are routed seamlessly through the Satoshi channels in the middle of the Lightning Network. And while this exact story is fiction, all of the technology used to do this is very much real and up and running today. I'll leave it to you to imagine what kinds of products and services you could build on this protocol, or how your customers might benefit from all of these possibilities. And now we'll walk through the Taproot Assets protocol that makes this all possible. The protocol is opt-in, it uses client-side validation, it requires no consensus changes, and you can use it on mainnet today, and assets are embedded in Taproot transactions, so even minting doesn't require high fees. We'll cover minting, transfers, channel opens, and Lightning payments all at a high level. If you would like all the details, don't forget to check out the docs at docs.lightning.engineering and all the other resources that we'll list in the video description. Let's imagine that Alice wants to mint a fungible asset, beef bucks. These beef bucks might function like a stablecoin, and so Alice needs to mint her first round of these assets. Alice will decide how many beef bucks she is going to mint. She'll set this asset to fungible, add any metadata that she wants to include, etc. And the Taproot Assets daemon, or TAPD, will then construct a set of specialized Merkle trees to store all of this data. The specialized Merkle trees used here are called Merkle sum sparse Merkle trees. This structure allows Alice to provide cryptographic proofs to show that she does or does not hold a certain asset and how much of that asset she holds. Also, a set of Merkle trees are used here in layers. This structure allows us to require private key signatures at different layers, and this adds both to the security and the flexibility in use cases. So now that Alice's node has got all of this data, how do we add it to the Bitcoin blockchain? Now, non-technically speaking, we just sum up all of this data and then we shove it into a Bitcoin address. But a bit more technically speaking, what we do is sum up this collection of Merkle trees to a root hash, then we add that root hash to the Bitcoin script tree, and then we add all of that to a Bitcoin address using Taptweak. To anyone looking at the Bitcoin blockchain, our minting transaction will appear to be just a regular Taproot transaction. No one will know that we shoved all that data in there unless we give them the cryptographic proofs. And this is what we mean by client-side validation. If someone has the data, they can prove that those beef bucks were minted and in which transaction they were minted. But someone without that data has no idea that this has happened. Doing it this way has a lot of advantages. It adds to privacy, it keeps transaction costs low, and it's just an elegant use of block space. And let me help you visualize where this data lives. Of course, all Bitcoin transactions have inputs and outputs, and we can think of these assets as living in a Bitcoin unspent transaction output, or UTXO. Now let's imagine that Alice wants to send some of her newly minted beef bucks to Bob. What Alice and Bob's Taproot Asset nodes are going to do is take the current set of Merkle trees where Alice's beef bucks currently live, that's embedded in a Bitcoin UTXO, and use that to construct two new sets of Merkle trees. So if Alice has 1,000 beef bucks that currently live in one Merkle tree, they now need to construct 2 new Merkle trees, one where Alice has 900 beef bucks and the other where Bob can hold his 100 beef bucks. Now to send these assets, Alice can take the UTXO that holds all her 1,000 beef bucks and use that as an input to a transaction that has at least 2 outputs. One of the outputs will go to Alice, and that will hold the new set of Merkle trees, which stores her 900 beef bucks, and the other output will go to Bob and hold his set of Merkle trees with his 100 beef bucks. A quick note here is that we can also do a sort of internal transaction where we move assets from a leaf on one tree to a leaf on another tree, all within the same set of Merkle trees. Now this would also require an on-chain transaction to commit to the updated state of these new set of Merkle trees, but this provides for some very interesting use cases. So we've looked at on-chain transactions. Now let's look at how we can add assets to Lightning channels. If Alice holds a UTXO with assets in it and she wants to open a channel with Bob, she can use as an input the UTXO that holds her beef bucks. You can imagine that a bit like this. But this time, the new transaction output is used to create a Lightning channel. To sum that up, we can take a transaction UTXO that holds assets, and we can use that to open a Lightning channel, and we will have both Satoshis and assets in that channel. Once that channel is open, Alice and Bob can send assets back and forth to each other, updating the asset balance in that channel. In this process, there is of course some additional coordination required between Alice and Bob's nodes, but on-chain, this is going to look like opening any other Taproot channel. Now we are getting really close to having an understanding of the multi-asset Lightning network as we described at the beginning of the video. There's just one more piece missing, and that's how do we route these asset payments across the broader Lightning network? How do we have a situation where Bob sends out one asset, but Elena on the other end of the network receives a different asset? The concept we need to discuss next is the edge node. So let's imagine that Alice creates the Alice wallet, which is a Taproot asset enabled wallet and operates an edge node as a service to her customers. Bob, Carol, Diego, and others are her customers, and Elena and Frank are connected to another edge node elsewhere on the Lightning network. The Alice wallet and her edge node support a US dollar stablecoin, and Bob, Carol, Diego, etc. are all people who wish to transact using a USD unit of account, and so all of them have asset channels with Alice's edge node. Alice's edge node also has regular Satoshi channels opened to connect it to the broader Lightning network. Now let's imagine that Bob wants to buy some services from Elena, who wishes to receive a euro-based stablecoin. When Bob goes to send his payment out, first Alice's edge node will do the math to calculate how many assets Bob needs to send her before she sends out a Satoshi transaction to the next hop on the broader Lightning network. And yes, there is a whole process that happens here, and you can dig into all of that, of course, in the docs. But once Alice crunches those numbers, she can then forward the payment as a regular Satoshi-based Lightning payment. That payment will route through the network until it reaches Elena's edge node on the other side of the network. Elena's edge node will crunch the numbers to convert that payment from Satoshis to a euro-based stablecoin and will update its channel balance with Elena, thus completing the payments. And in this way, Bob sent out a USD stablecoin and Elena received a euro-based stablecoin. But Bob, Elena, and the edge nodes have a bit of coordination to do that is managed by their Taproot Assets nodes. But after that's happened, the payment is routed just like a regular Lightning Network payment, and so it has all the same liquidity functionality and security features as any other Lightning Network payment would. And that's it. If you've made it this far, congratulations, you understand Taproot Assets and how the multi-asset Lightning Network functions. If you'd like to dig into anything discussed here, please have a look at all the links in the video description, and as always, don't forget to check out the docs at docs.lightning.engineering.